Record. Okay. So yeah, so I hope you guys all enjoyed your spring break. And if you have a question, keep your hand up. So it looks like Aubrey is the only one that has, oh, I need to take it down. No questions at all. Okay. Well, so I want to go ahead and start off where we left off last time. And we're gonna have some people that are gonna keep joining the meeting. Hey, Efren, you had a question?
Yeah, pretty much for like the last 5 of the Monopoly homework.
Yeah, and so I was thinking about that before we even got together. And so I was thinking, well, normally in this beginning session, we'll go ahead and solve problems. But we still don't have all the tools in place yet. So I think I'm going to switch things around and finish off the lecture and make sure that we understand how to aggregate these marginal cost curves. And I say aggregate the marginal cost curves because whether you're talking about what's happening in competition or in monopoly, in both cases, you're doing the same thing. You're adding up the marginal cost curves together. You're getting aggregate supply from the individual supply curves. Because remember that the marginal cost curve is the supply curve. So hopefully everybody feels comfortable with switching back and forth. But if I say anything that's confusing, if the not the math should be clear no matter what. But if I say something that's confusing and you think, oh, well, Dr. Hunter, did you mean supply or did you mean marginal cost? And you were talking about it in this one context, and maybe did you mean it this other way or something like that? Then you should ask me to clarify, because all of the language that I'm using at this point in time should be clear for you guys to understand when to use the math that we're talking about. So hopefully that answers your question, Efren. And if not, then raise your hand. But we'll go ahead and we'll get started doing that. And okay, I'm trying to manage my windows so I can see everything that I need to see. Okay. Okay. And okay. So hopefully I got this managed. Okay. So in order to begin answering the questions that we want to answer, okay, I gotta try to get the whiteboard ribbon to cooperate. Okay. That should be good. Okay. So this is our general topic. And let's try to move this to the top of the whiteboard. Okay. So we said that this would be the case whether we were talking about an individual market and analyzing under competition, or in the case of a monopoly. And we explained that math last time. I posted the lecture so you guys could go back and skip to the stuff, particularly the stuff we were talking about at the end. And then after this, we should be able to go ahead and solve any of the problems that we see on Ignithium. Okay, so we're going to start with the case that we have two firms, and that these are the general forms of the marginal cost functions. Now, remember, and I'll go ahead and start a new little text box over here. And I'll label this one so remember that what we're talking about is this three-step procedure. And for the three-step procedure, remember the first thing that we do is invert, and then the second step is add, and then the third step is invert the result of 2. And you guys might want, right, to try to do something other than this, but if you do, your math just won't work. so you know, I caution you against that. And then remember, the other thing that we have to do is we have to observe, right, that you're going to have a resulting, and we could call this, you know, a resulting marginal cost curve. We could call it, you know, the sum of the marginal costs, right? But specifically, we're talking about the horizontal sum, so things are going to be a little bit different. But when that happens, right, then there's an implication that the marginal costs, and we talked about this last time, the marginal costs of the two firms are going to be equal to one another. And so we want to make sure that we're going to use that observation. And the other thing too is that the resulting quantity, and I'm just going to call it the sum Q that we're going to end up getting, is we're going to end up having, I'm going to call it just Q by itself, and this would be the quantity that's produced by the monopoly or the quantity that's produced by the competitive market. It could be either one, but it's going to be the sum of the quantities produced by the two production facilities. Now, again, I'm playing with the language a little bit to get the idea across that literally what's happening, and I had explained this last time, if you remember, that when you think of competition and when you think of monopoly, you want to really think that the firms have characteristics that are different from one another, but that's not really true. The only thing that's happening is if you think of the competitive market as being a bunch of relatively small firms that have these little factories or little production facilities and they're competing with one another. The only thing that happens under a monopoly is the production facilities stay the same. They don't become one big factory or whatever. Instead, they just start coordinating their output together. So that's also the reason why um, I don't know if you guys paid attention in your principles textbook. You know, we have two textbooks that are available for the class online, and reading the monopoly sections of both of those textbooks would be useful. Even if you give them, you know, I wouldn't say, you know, a really thorough reading, but you know, a good once over, just to make sure that you understand the concepts that are being discussed. But when in the early 20th century, there were lots of laws that were passed by Congress to break up um, industrial monopolies in the oil and the steel industry, for example. And the real issue there, and if you look at antitrust law today, one of the key things that is outlawed is price fixing. So if you think of a bunch of people in a competitive industry, or a bunch of firms in a competitive industry having these individualized production facilities, and then behaving like a monopolist and engaging in price fixing, then that's what a monopoly is all about. The only difference is that if there's some sort of price fixing scheme that is agreed to informally, then you know there, and this is what we'll talk about a little bit later, and I'm just using price fixing as an example. The other thing that can happen is output targeting, and that output targeting or the quantity fixing is really the mechanism by which, you know, most coordination happens, has happened in the past, and the one um, that we study most closely when we're first introducing these concepts. But when firms are coordinating to price fix or to quantity fix, they're behaving like a monopolist, and we say that they're colluding. Now, there's an issue here between um, tacit collusion, and tacit collusion is informal collusion. It's, you know, the head shake or the nod, like, yeah, we'll do that, but there's no way that the firms can um, well, first of all, uh, under current laws, right, that type of behavior is illegal. So if they agree informally to cooperate, and the colluding members of the organization don't follow through, if they cheat, or they, the word we're going to use later is if they defect on the deal, then the firms that are injured by that lack of coordination, and we'll be able to show that there are, you know, real injuries that happen if I say I'm going to do something and you don't, and part of that agreement was we were going to share some benefit, and you don't follow through in the agreement, then it's going to cost me profits at the end of the day in the context of a firm. So if you cheat on the agreement, if you defect from the agreement, then there are real economic injuries. So the the big picture is that in an informal, or again what we will call tacit collusion, that's the common term that's used in economics. In a tacit or informal collusion setting, If one of the firms cheats, there's nothing they can do about it. So really what the monopoly does is they create a formal contractual setting, and the one that you guys should be top of mind about, the one that should first come to your attention, and you might not think of it as a contractual setting, but a lot of people have described a business, a firm, what we call a firm, a business firm in economics, as just being a bundle of contracts between workers and the people that own the equipment. It's just a bundle of contracts. So, and those contracts legally bind, right, with the force of law, behavior. So all a monopolist is a formal contractual relationship between these different production facilities to coordinate their output and their pricing. But the facilities themselves are exactly as they would be if they were, a competitive firm. There's not any difference. They're not bigger or anything like that. And you guys know that all along the whole idea is that firms are going to choose their production capacity and the size of firms that they produce at to minimize their costs in competition and in monopoly. So if the competitive arrangement, whatever it is for the industry, is the one that minimizes the cost of the industry, then the monopolist would choose exactly the same thing. There's no reason to think they would do anything different. The only thing the monopolist is doing is a formal way of coordinating output. So and we'll see that there are economic benefits in terms of market power to the monopolist, because what the monopolist does at the end is they restrict the quantity of output to drive up their profits, and that coordination has benefits to them. So okay, but mathematically, um, I just want to make clear that this is our procedure, and we need to make use of these two observations if our math is going to work out the way that we want it to. So our step one, we said, was we want to invert these equations, and or I'll say invert MC1 and MC2. So you guys should observe now that if we do that, remember, we're going to drag the quantities over to the left-hand side. And so we would end up with D1 Q1 is equal to MC1 minus C1. So this is really similar to what we did before. The only difference is that now we have this constant to drag around, and that's going to make the algebra a little bit messy. And so from there, we can say, okay, well, Q1 is then going to be equal to MC1 divided by D1 minus C1 divided by D1. Okay, and so if you guys see an algebra error or anything doesn't make sense to you, then go ahead and let me know. And I would do the exact same thing for Q2, but it's going to look very similar, so I don't have to be quite as detailed in the result. Okay. So there are two inverted equations, right? And then we said our step two was to add the result, right? So here we're going to end up with Q plus Q2 is equal to, now, well, I'll go ahead and just write everything out. Oh, and let's see. Okay. Gosh. Okay. Mhm. Okay. Yes, somebody asked a question and I'll or made a comment in the chat, and we'll talk a little bit more about that in a minute. So I guess I made a few corrections because obviously there was a typo here at the beginning, but I'll ask right now, does anybody have any questions about any of the algebra or anything that I've done here? Okay. Any questions? Oh, I don't see any hands. Okay. So then I'm gonna go ahead and see if I can. I'm trying to select all this so I don't have to retype as much. Mm, okay. And okay. So I'm gonna erase some of this stuff in a minute, but now I just want you guys to see. Now I'm going to go ahead and use these observations, right? This one and that one. And I'm gonna actually do that before I get to step 3. Okay. So So I'm using those two equations at the top. So I know that I can just reduce this to Q, which is the aggregate Q, right? And then I can replace MC1, because MC1 and MC2 are equal to one another, with just MC divided by D1. And actually, I'll make my life a little bit easier. Okay. And I'll just get rid of the subscripts. Boom. Okay. And now our last step is to invert the result. So since we got down to this line here, then, and I'll move it over so it's aligned, right? This is our big intermediate step, right? And so, well, I didn't want to bold the whole thing, but that's okay. And I'm going to go ahead and delete that stuff. Well, I only wanted the bold part of it, but it won't let me. So anyway, that's fine. So our last step is to invert this result. And so I will get you guys started. You want to end up with MC equals something, and it's going to be a function of Q on that side. Okay. So now I'll give you guys a chance, and it's just a little bit of algebra. But go ahead and invert this and simplify it. So go ahead and invert this and simplify it so you end up with something like that. And then we'll talk about it. We'll compare answers. Okay. So and you guys can just spend like 5 minutes on it, and then we'll compare answers. And then when I ask you, you can go ahead and type your result in the chat box. Okay. Does anybody have any questions? Okay. So go ahead and get started, and I'll give you a few minutes. Okay. Okay, so we're back. And I'll go ahead and look at the chat. So does anybody have an answer? If you have an answer, okay. So Greg, you're just a little bit enthusiastic there. So which I admire enthusiasm, don't get me wrong. But I was gonna sing the song, if you think you know the answer, raise your hand. If you think you know the answer, raise your hand. And by the way, I will say this, which is, I do not endorse your answer. So if anybody else has an answer that's the same or different, and they want to endorse it, then I'm totally okay with that. So are there other answers? Okay. Well, then I have to ask, sing the other song, which is, if you don't know the answer, raise your hand. If you don't know the answer, raise your hand. Okay. 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 Good. Good. So I'll just start with a few folks, and so Efren had raised his hand, and I guess he put it down. Efren? So you don't know the answer?
Yeah, totally. I don't.
You don't. Okay. So let's take a look at this, for a minute. Are you with me?
Yeah.
Okay. And I gotta move my group chat window out of the way. And so if you look at the equation, and I'm gonna get my arrow, so I'm talking about this one here, right? Then what you see is you lack like common denominators, right? You follow me, Efren?
Yeah.
So the first thing that you should do is construct a common denominator for these terms. So I'll kind of help you out. So remember that you can multiply anything by 1, and then you don't change its form. So for the first term in that equation, we should multiply by d2 MC divided by, and since it's multiplying by 1, we're multiplying by d2 over d2. So our denominator should be d1 times d2. Does that make sense?
Yeah.
So I just rewrote that, only the first term there,
Only
right?
the first.
Yeah. So you want to try the second term?
Let me give it a shot.
So I don't know if do you want to type your answer in the chat? You can do that for the second term. Or you can just tell me what you think and I'll type it down. What do you think I should multiply the second term by in order to get a common denominator?
Just be D1, right?
Well, right, but I should actually be multiplying by D1 over D1.
Oh, yeah. So
right, because I have to multiply by 1.
Yeah.
So the result then should be D1 MC divided by, and I'll just write D1 times D2. Okay.
Okay, that makes sense.
Yeah, does it? I mean,
Yeah.
yeah. And then these other terms, right? They also, the constants need a common denominator, right?
Yeah.
So you want to help me out with that one? So I should write,
So far, the next one, would we just be multiplying by d2 over d2?
yeah, right? So it's d2c1 over d1 times d2, right? And then I'll expand the window a little bit more. And then the last one is
Just d1 times c2 over d1 d2.
yeah. Okay. So now you have them over common denominators, right? And so now we can simplify, right?
Yeah.
So, I mean, you could write it any way that you wanted to, but why don't we go ahead and I'll ask somebody else if they want to in the chat. How about Ian? You have your hand up. You have your mic, Ian?
Yeah, I'm here.
Okay. So you want to simplify what we have now for us?
Okay. So we have common denominators, so we can add everything in the top together.
Yeah, just add the numerators, right? So
Two.
I would probably write it this way, just because I put the D1 first, because
Right.
not, right? I mean, I don't have to, but it just looks prettier that way. And so then we got to be a little bit careful here with our parentheses, right? Because we have a
Yeah. I see.
we have a numerator, and then in our denominator we can be less careful because it won't cause too much confusion. So D1 times D2.
Two.
So that look good, Ian?
Yeah.
So why don't you guys collectively work on simplifying the constants, and then we'll move on to the next one. And so go ahead when you have the last two terms simplified, go ahead and raise your hand, and then we'll finish it up. Thanks, Ian. Okay, so Shelby, you have your hand up. You have your mic?
Yes, I have my mic.
Okay, did you want to simplify the last two terms for us?
Yeah. So I have it in the chat. You want me to put it in the chat?
Yeah, that's fine. Okay, yeah. So I agree with you. The only thing that I would do at this point in time, just kind of in anticipation, is I would just factor out the -1.
Okay.
And and then again, it's not a big a deal one way or the other. Everything you have is correct.
Okay.
But maybe it's because we have the D1 and then D2 first of the first terms. So like I like to keep things parallel, so it's easier for me to see if
Okay.
I made a mistake, right? Because if you see a lot of symmetry in the equations, then if you write things in a way that's similar, then you can see if you made a mistake more easily, especially when you're just dealing with symbols. But your answer is correct. And
Alrighty.
and does anybody see? Does everybody see what? So you see how I dragged the minus sign out there in front, Shelby?
Yeah.
Yeah. Um, I dragged the minus sign out in front, and I gotta be careful. Yeah, you're right. Blah 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 blah. Okay, there. Yeah, Jin came up. We made a typo here as we were expanding our inversion. So hopefully everybody can see. Okay, so are there any questions at this point in time? Okay. So if you have a question, go ahead and raise your hand. So, okay. So now you guys should be able to see the next part of what's going on, right? So if we want to invert this, then what should our next step be? If you notice what it is, then go ahead and raise your hand. Nobody has their hand raised. Oh, Aubrey. Okay. Tell us, Aubrey.
Would you like cancel out common factor, like
So when you say cancel out, just tell me
like,
mathematically what you want me to do.
like, wait, that doesn't make sense. Never
Well,
mind.
no, I'll kind of help you since you're
Okay.
here. Okay, right? You can multiply both sides of the equation by anything, right?
Yeah.
And ultimately, we're trying to get MC back over because we're inverting, right? We're trying to get MC.
Yeah.
That's why I kind of anticipated too early, and Jin corrected me, right? We still have our Q's on the left-hand side. So if we multiply both sides by that D1 times D2, then we'll start to isolate our MCs the way that we want to, right?
Yeah.
So do you just agree, or does it make sense?
I think I'm a little bit confused, but
yeah. Okay. So since I mentioned it, does anybody else see what we should do next? Thanks, Aubrey. Okay, Greg.
Yes. I think the right move is to multiply both sides by D1, D2.
Yeah, and so And I had mentioned that. So, but if we do D1 times D2, and I'll just put times Q to make it, you know, more transparent, then I'm going to be multiplying the other side also, right? And then I'll just end up with, and let me see if I can just copy this line. Okay. And then since I'm multiplying, and hopefully everybody can see this, but I'll just be really explicit. And I'm multiplying that whole thing in the square back brackets by D1, D2 also, right? So then I can copy this and paste it. And you guys can see that the D1 times the D2 is going to distribute over both of these terms. And in the result, we're going to end up then being able to get rid of the D1 times D2, right? Does everybody agree? Do you agree, Greg, with the result?
Yep, I do.
Okay. So then we're almost to our last step. So we should be able to go ahead and bring this home. And I'll copy this and paste it there. And then I want to make the observations that these MCs can be factored out. And somebody, well, Shelby actually mentioned that in the chat. So, so everybody sees what I did there. So we factored out the MC. And then what I'm going to do is I'm going to add this constant term to both sides. And I'll just, again, be really explicit. So hopefully nobody gets confused. So I'm going to add that there. And I'm also going to add it here. And okay. And drag the window up a little bit so we have just a little bit more room. And then, again, without being or trying to be very thorough, right? So now, right, it doesn't matter what we have on the left-hand side or the right-hand side. We can switch things around at this point in time. So I'm going to go ahead and simplify because I have minus D1 times C2 plus D2 times C1, and I added the same thing. So that's going to be 0. So I just get rid of that. And okay. And then you guys can see the last step is going to be to multiply or divide, however you want to say it, you know, by multiply by 1 over D1 plus D2, or to divide by 1 over D plus D2. So I'm going to take all this stuff here, copy it and move to the next whiteboard. And okay. Are you on your iPhone, Efren? Stop the video. Stop the video. Stop the video. Okay. Okay. And, right. So then we have MC is equal to, and then I'll take all of this. And now, obviously, we're just going to divide both sides by D1 plus D2. And then I'm just going to rearrange things a little bit to be explicit about what the coefficients are. So maybe it looks better this way if I do a square bracket. And okay. So that's our final result. Okay. Now, does anybody have any questions about what we just did? I mean, we're really explicit about the math, and this is being recorded. So if you want to go back and review it, you know, we made a few typos and then we corrected them. But does anybody have any questions at this point in time? Questions? Okay. So oh, you have a question, Greg? Go ahead.
Oh, sorry, I forgot to lower my hand.
Okay. Okay. Yeah, no, it's totally cool. Okay. So I want to introduce a new term here and explain, because we're almost all the way there, because you would think, and I know you guys are probably thinking to yourself, well, gosh, you know, we did so much work. Are we finished? And so I guess I'll put, sorry, you are not done. And so if you guys ever, you know, wonder to yourself, you're like, well, what did I learn in college? Right? Well, I'll tell you guys. I mean, you're learning lots of stuff, but you know, if somebody told you to aggregate these even if you did math, because I know you guys have done plenty of math, and all we've done is algebra. But if you're going to aggregate these marginal cost functions, if you're going to aggregate these supply functions, you're still not done, and the math won't get you where you need to go, because the disappointing fact is that, and you have only derived the JointMC. Okay, now, so the joint marginal cost function is, like cool, right? But it turns out, kind of like we talked about the marginal cost curve, remember that the supply curve of the firm is only that portion of the marginal cost curve that lies above the minimum of the average variable cost. So even though, and again, this is part of being in an applied math discipline, even though we casually talk about the marginal cost function as being the supply curve of the firm, it's not really, right? Because it's only that portion of the marginal cost curve that's above the minimum of the average variable cost. But we don't go around saying that all the time. It's like inside knowledge. And you guys are now, becoming insiders. Just in the same way that when we talk about costs, we don't always say opportunity cost, opportunity cost, opportunity cost, because you guys should know that, economic costs are the full opportunity costs, and we're not talking about merely accounting costs. In fact, as an aside, I saw an interesting article that was recently published in a journal. I didn't read the article, but I could tell what it was about right away. But it was an analysis of the difference between accounting costs and like the true costs of the firm. So as I told you guys before, that figuring out how to measure implicit costs, the cost of idle equipment, or the cost of the owner's time of the firm, or some other cost that a firm bears that they don't have a receipt for, it's hard. And so, the idea that people are doing analysis and ongoing research and trying to perfect the measures of, the full opportunity costs isn't at all surprising, because it's not something that, you could teach with precision generally. In fact, I'm pretty sure, and I don't know this for a fact, I know a little bit from some of the consulting work that I've done, but I imagine this extends to lots of different industries, that once you're an expert in like the poultry industry or whatever, you're aware of what the implicit costs are and how to factor them in your analysis. But when I was doing work for, the consulting work that I was mentioned, we had factors that we would add to the cost of capital, that would differentiate the cost of capital from what you might see just in an accounting spreadsheet, to account for that implicit costs of idle equipment and other things like that. So yeah, as you guys go on in your career, if you end up doing a lot of specialization in a particular industry over time, then you'll be dealing with a lot of probably data that's supplied by accountants, but you'll be modifying and tweaking it to try to make it more precise to measure the full cost. So the analogy that I was getting to was that, we talk about marginal cost as being this supply function of the competitive firm, but it's not really, right? We have to add that little piece in there about the minimum of the average variable cost in order to be precise. Well, here, the joint marginal cost function is not, either the marginal cost of the monopolist, nor is it the marginal cost or the supply function for the competitive industry, right? So in order, and obviously if you had a bunch of data, you could go ahead and process it and just use the math. But the next step, so this would be step 4, is draw a picture. And I only say the step 4 is draw a picture. And maybe I should say draw the picture, because without drawing the picture, really figuring this out is difficult. So let's draw a picture. So and you guys might say like make a graph, but it's not really a precise graph. It's just an illustration. So what picture are we talking about? Well, we want a graph and I'm going to call one of these firms the high cost firm, and you guys will know why I'm calling it the high cost firm. So we'll let the red one be the high cost firm, and we'll let the blue one be the low cost firm. Okay. So I'll draw it that way. Okay. So and okay. So I need a volunteer. If you'd like to volunteer, raise your hand. Nobody wants to volunteer. Come on, you guys. I know. See, now's the time. Okay, Greg, see, I was going to mention you because I know you're enthusiastic. So, yes. Okay, Greg, you with me?
Yeah, I'm here.
Okay. So notice that on the vertical axis, we're measuring dollars, right? And on the horizontal axis, we're obviously measuring output, right?
Right.
Right. Okay. So you're the manager of these. So we're going to assume they're jointly managed, right? You're the manager of these two, and the way to think about them is as two separate factories or two separate firms or two separate plants. I don't know what you want to call them, but they're different production units, right? But they're both under your control, right? Now, you're trying to maximize profits, which means you're trying to minimize your costs of production. And so do you see my blue arrow here?
Yeah.
Okay, so this is the price of the product. We're going to start it out at, you know, near zero. And so if the price of your product is, you know, close to zero, and in particular it's lower than the intercept there, it's lower than C2. So how much are you going to produce? Are you with me?
If the price is super low,
Yeah.
C2.
Well, okay. Now, if the price was down here, we know C2 is some number. We can go ahead and throw in a number just to be concrete, right? And I'll.
Well, I guess if the price is below their costs, they're not going to produce anything, right?
Yeah, right. So let's say C2 is $5. And then let's see if it'll let me move it over so it looks better. Yeah. So I'll go back to the arrow. So if the price is $1 and at your and by the way, let me be clear about this, right? It's very common for businesses to have different costs of production. And really, the reason that happens is because different technologies are available at different times. There's technological progress. And so like one really good example of this is the coal industry. So or actually coal-fired electricity, right? I don't know if are you with me, Greg?
Yeah.
Yeah, I don't know. Have you ever thought about do you know how coal-fired electricity is generated? Have you thought about it?
It's kind of just like a boiler, right?
Yeah. So they use the coal. I mean, it's basically like charcoal, right? It stays on fire and they burn it. And as they burn it, they create steam in this, you know, boiler. And then that steam pushes a turbine around. It's basically a big fan blade. And then that fan blade interacts with, you know, they have a copper coil and, you know, it's physics, you know, and you know, electromagnetism, and you know, it generates electricity. But you got to keep the steam going, so you got to keep, you know, fire on the boiler to generate the steam. So but you know, back in the day, back in the 1940s, 50s, 60s and before, when they're using these steam turbines and coal, they used to do it as you would imagine, right? Like the way that the turbine is designed, the material out of the turbine, right? I mean, I don't know if you guys, you know, like appreciate, if you ever see like, you know, like the Dyson fan, like there's no blade in it, right? It just blows. Like how does it? I don't know, but you know, like, you know, Dyson's some aeronautical engineering genius, and he figured out how to do these things. But the point is that as time goes by, the technologies improve, and in particular, they become more efficient, right? But normally what happens, so remember, like these, if we look at these marginal costs, so the low cost firm, it has a lower initial cost per unit, and then as you increase output, it has diminishing marginal productivity, but its costs of increasing the marginal costs are lower than the increasing costs of firm one. So what generally happens is you have some plants that have, you know, old equipment, and they have a relatively high cost of producing, like C1. And then as you use them more, they have a higher rate of diminishing returns or diminishing marginal product, and each additional unit gets more and more expensive more quickly. So yeah, if the price was down here at you know, at below $5, you wouldn't produce anything, right? But then as soon as you hit $5, you would begin producing, but where would you begin producing? At your at the
D2.
yeah, at the low cost one, right? And then if the price was still like at $6 here, and let's say C1 is like at $10, would you produce anything at all at your high cost factory?
No.
No, right? You would go here and here and here as the price slowly crept up. And then eventually, because of diminishing returns, you would end up getting to some point where the cost of producing an additional unit, the marginal cost at your low cost plant, was equal to C1, right? And then at that point in time, suppose that you're facing some price that's higher than C1. And again, I guess just to be explicit, we can say, this is equal to $10. And then I'll move it around so it looks a little bit prettier. Okay. And so we get to $10, and then you go, oh, well, what if the price is $20? Then what do I do? Right? So what do you think happens then?
You'd be producing at both plants, I guess.
Right. So you'd be producing so many units at this plant, the high cost plant, and so many units at the low cost plant, but you would never want to produce so many units at the low cost plant that your marginal cost of production was higher, because remember, your marginal cost of production is the cost of producing a specific unit, so you'd never want, and I would like to use the term per unit cost, but it's confusing because per unit cost is often used to mean average cost, and we're not averaging here, right? But you'd never want to produce at one plant where you're producing at $20 a unit when you could produce some units for less than that at the other plant, right? It's just kind of common sense. So you follow me, Greg?
Yeah.
So the point at which you would begin utilizing the high cost plant, and I'll draw another line here, right? And maybe I'll draw one with an arrow, and I'll make it orange. Okay. So with the drawing tools that I have here on Zoom, that's like the best that I can do. But it's okay. So I would produce only at the low cost plant until, because of diminishing returns, the marginal cost of producing at the high cost plant was equal to the marginal cost at the low cost plant. And then I would begin producing some at both. But obviously, like, the mixture is that, I would have more production. I wouldn't equally divide it. I would divide it so I could keep those marginal costs equal. So I got the least cost per unit. Okay. So the next thing I want to do is I'll draw and I'll put it in purple. So if I do this right, the joint marginal cost actually passes right through that point. Okay.
Okay.
So now note that we know that this, and I can go back for a minute just so you can see, but this constant term, and I'll select it. This constant term okay. Can you see that? It's a mixture of C1 and C2. And it ends up being in between them. And if we had the D1 and D2, we could figure out, is it going to be $7.50 or whatever that constant's going to be, but it's going to be somewhere between C1 and C2. I point that out because when you're drawing this picture and after you figured your equations, you want to make, if for whatever reason you were to end up with a constant for the joint marginal cost that was not between the two intercepts of the individual marginal cost functions, you did something wrong. So that's something to bear in mind. And then the other thing is that if you want to know where does the joint marginal cost function cross the marginal cost of the low cost firm or the low cost plant, well then notice that I can set, and I'll write it down here, I'll call it Q cross, right, for the crossing point is defined by where C1 is equal to, well, MC2, right? So I can just set C1 equal to C2 plus D2 Q2 and solve for Q, right? And that will be the Q cross, right? And so I don't, does everybody see what I'm talking about here? Do you see what I mean, Greg?
Yeah, I do. I just have a quick question about the intercept. Would that be a midpoint or is that kind of a weighted average?
It's a weighted
'Cause
average.
Okay.
It's
gotcha.
exactly a weighted average. And Ian, did you have a question? You can unmute yourself and chime in.
Yeah, I did. I'm having a hard time sort of understanding how if the purple line is a combination of both firms, why wouldn't the slope be in between those two firms? How come there's actually a crossing point?
Well, yeah, okay. So it's a good question, right? So you're thinking that like it should be like right in the middle of the two of them.
Something like that, yeah.
Well, and that's a fair enough observation. But remember what we did was, and mathematically, right, is we took the horizontal summation of this one and that one, right? Even if you didn't do the math, if you just had a table or something like that, right? And I said to you, oh, take the red one and add it horizontally to the blue one, then you would know, oh, well, let's just take some point where we're going to be using both of them. I would take this quantity here and add it to that quantity there. So it's all of this distance, right? And then I add this distance here to it, right? So I'm going to end up with something way over here.
Okay. Gotcha.
So if we've done the math right, we should end up with, a joint supply curve, or, a lot of times you guys have done this in the context of a market supply curve, a market supply curve that has a slope that's less than the slope of the individual supply curves for the individual firms in the market. So the only thing that we did differently here is we did, the math that we showed you here, and it turns out, if we did all of our inversions and adding together properly, we'll end up with a line that reflects that logic, that the market supply curve has to be to the right of the two supply curves of the individual firms. Does that make sense, Ian?
Yes.
Yeah. Okay. So anyway, the point that I was making with Greg, you have your hand up still, Greg, or you just because of me? Okay.
No, that was my bad.
Oh, yeah, no problem. Okay. So, but the point that I'm making, and normally when I do this on the board, I can, draw dashed lines, but I can't draw a dashed line here. So, sorry. But the point is that the portion of the joint marginal cost curve that is above the minimum of the low cost firm does not apply. What actually happens, and I'll draw another line here, and it'll be purple, is that you follow along, and these lines are actually the same line, but I'm just drawing them next to each other only because I'm trying to emphasize that you're going to follow along the blue line, and then once you get to the joint marginal cost curve, and I'll draw one more line in. The only other color they give me is light blue, and I don't have the ability to draw a dashed line, so I'll do in light blue. Oh, it's moving it. Still, I'm getting movement here. Okay. Okay. So this is everything that I wanted to draw for you guys. And hopefully you guys see why you have to draw the picture, because the math won't tell you, right? This light blue portion of the joint marginal cost function, the portion that lies above the portion of the low cost firm, you would never produce using that that segment of the joint marginal cost function. So it's only that portion of the joint marginal cost function that lies above the intercept of the high cost firm that actually represents the marginal cost of the monopolist, or the supply of the industry, if it's a competitive industry. So, Greg, does that make sense?
Yeah, it does.
Yeah. Okay.
Thank you.
So the real point, and I'll kind of bring it back here, is that the and you guys might remember, you know, we would actually call this a piecewise function. Okay. The monopolist is okay. And so if we were going to, and it doesn't really make a lot of sense here because you guys, based on Ignithium, you have to observe, right? Is either firm 1 or firm 2 the low cost firm? If firm 1 is the low cost firm, then the monopolist is going to be producing according to C1 plus D1 Q1 until it hits C2, right? Which is the lowest possible cost for the high cost firm, if that's the if C2 MC2 represents the high cost firm. And then it's going to move over and begin producing along the joint marginal cost function. So those are the two pieces, and I'll write that down. The produces along the low cost firm Okay. So hopefully that makes sense. Does anybody have any questions right now? Okay. So those are our pictures, and now I want to say one other thing before we go any further, and I don't know if there's a good way to select like all this stuff. I don't think so. Maybe. Mm. It won't let me just copy all of this. Okay. So let's see. Yeah, it doesn't want me to copy it. So I'll do my best to draw something similar very quickly. Okay, so the point that I want to make is that you guys are going to see problems on Ignithium. Some of them will be easy because you guys will note it is possible for C1 and C2 to be equal, in which case the joint marginal cost function is just going to have the same intercept and you know, be a ray out of the origin, almost like what Ian thought about, but it's going to have a flatter slope. So it'd be better to like draw this and that, and then draw another one more steep. So if the two steep ones were MC1 and MC2, then the joint marginal cost would be MC3, and there would be no issue about, you know, do you produce at one of the plants first or anything like that. But to handle the cases like we discussed, then we need to be aware if this is the low cost firm and this is the joint. So I will label these. So I just have the low cost and this one is the joint. Okay. So typically the problems are going to involve, remember, you're going to have it could be demand or it could be marginal cost, right? But you're going to have a line crossing down here. Let's say, and I should have said demand or marginal revenue, but let's say this is the marginal revenue for the monopolist. Well, notice that, and I need another volunteer, someone to talk to. Who wants to talk? Nobody? Okay, maybe I select a volunteer. Okay, hey, Danny, do you have your mic on?
Yeah, I do.
Yeah, okay. So notice, Danny, right, that the joint marginal cost and the marginal revenue here will cross at a lower quantity of output than it crosses for the low cost firm. Do you see that?
I do.
So one of the ways, like in the problems, I'll tell you guys the way to solve the problem is solve for both where the marginal revenue intersects the joint. So that's one set of simultaneous equations. And then solve for where it intersects the low cost firm. And as long as you're on the left side of the crossing point, which means you should be producing at the low cost, along the low cost firm's marginal cost curve, you'll end up with a higher level of output. So you see what I mean? But notice, and I'll draw one other picture. If we were at a crossing point over here, right? Do you see what I mean, Danny?
Yeah.
So if we're at a crossing point over there, then the relationship is reversed. Then you end up with more output along the joint than you do along the low cost. So remember, whenever you're to the left of this crossing point, you want to choose to produce along the low cost firm's marginal cost curve. And when you're on the right point, that's when you want to produce along the joint marginal cost curve. But the only way to really detect mathematically on which side of the crossing point you're on is to compare the levels of outputs at the low cost marginal cost curve intersection with the marginal revenue curve and the joints marginal cost curves intersection with the marginal revenue curve. So you'll have to solve both and choose the one with the higher quantity. Does that make sense, Danny?
Yeah, that's cool.
Yeah, so I'll just write over here, choose the output that is highest. Oh, highest. And when you guys go back and review this lecture, if you're trying to solve the problems, then that should help you. Okay, so questions, comments, anybody? Okay. So I'm gonna stop sharing my whiteboard and okay, and I wanna share my screen and there we go. Okay, so let's go ahead. Can everybody see the monopoly problems from Ignithium? Okay.
Yeah.
Okay. So, and let's see here. Oh, I'll change the problems just to refresh. Yeah, because it's been idle for a while. Okay. So now you guys were asking about the last couple of problems, and I'll just point out the language, and then we can work on these on Thursday. So now you guys know what the joint marginal cost function is, and yeah, so you guys should be able to solve for those things. And then down here, we use the language of cartel. And so what does cartel mean? Well, cartel is just tacit collusion. It's an informal monopoly. And we assume that the cartel is going to behave like a monopolist, that that's their objective. Now, whether or not they can actually sustain monopoly cooperation or not, if you guys remember back from principles of economics, you realize that there's a lot yet to be considered about whether or not they'll be able to maintain cooperation. There's this is normally where we illustrate, and I'll use the language you guys might be familiar with, the prisoner's dilemma, in trying to get more profit and the tension in cooperation there. But for our purposes, you guys can just read cartel here as though it's a monopoly cartel. They behave like a monopolist. And then we could go ahead and solve the problems. So we have just about 10 minutes left, and this should be enough time for us to begin. So let's go ahead and take question 15, right? So you guys go ahead and solve question 15. Remember, we're looking for the slope of the joint marginal cost function, and I'll give you guys 5 minutes to do that. Remember, if you can't think of what else to do, just remember, the steps: invert, add, invert again. And this should be easy as long as you guys are careful, and you have a calculator, because they're numbers, and so the factoring out in order to isolate certain terms and make them algebraically nice to look at shouldn't bother you. Okay, you guys have any questions? Okay, so solve question 15. Okay, so I'm taking volunteers. So what's the slope? Go ahead and, okay, Greg has raised his hand. You know what? They did something weird. My participants window is not working. Okay, there we go. Okay, Greg, what'd you come up with? You want to type it in the chat?
Yeah, sure. Yeah.
Okay.
I basically labeled like D1 and D2, and using the proof, took that part of the joint MC formula that was corresponding to slope.
Okay. Greg! Good job.
Thank you.
Yeah, there were a bunch of people clapping all over Southern California right now. You guys all clapped, right?
Of course.
Yeah,
Of course we did.
yeah. Okay. Does anybody have any questions for Greg?
That wasn't as hard as I expected it to be.
Is that it doesn't sound like a question, Ian. That sounds like relief. Sweet relief.
Really,
Yeah. Well, right. Like when you do this stuff generally, it's like a little bit more complicated. So let's go ahead and we'll do number 16. So I don't know if you guys did 16 too anyway, but does anybody have it? Well, I'll tell you what I'll do, because we're getting low on time. I'll show you guys the answer, right? And I just want to point out here that they're doing things a little bit differently than what I did in the lecture. And I knew that they did this, but I still wanted to like make the point the way that I did, because anyway, I thought that it would be confusing to change the language. But notice that here they're just saying, okay, the true joint production is going to take place along the low cost firm first, right? So they're not computing the joint marginal cost function and then saying, oh, that point below the crossing point just doesn't apply. They're just saying, no, no, no. The joint marginal cost function actually is a piecewise function that starts at the low cost, right? And then the function that we computed is still there, but we're just going to get to it later. So I thought it was better to actually call the joint marginal cost function, you know, something to give that line a name, and then to point out that the monopolist marginal costs. So if I was going to change the language here, I would just say, I would get rid of the word joint there and just say, what's the intercept of the cartels? Because cartels monopolist, the monopolist marginal cost function, which is that piecewise one that we were talking about. But because the language up here is referring to the slope of the joint portion, it's probably a little bit confusing, but hopefully everybody understands what's going on. Are there any questions about that, about the language? Okay, and then I'll go ahead. So now this one I'll set you guys up because we only have 2 minutes left, and you know, we'll consider another problem. But this is where you have to say, okay, now I know what the cartel's marginal cost function looks like, and I have information here about demand, so I can compute the marginal revenue. And then you have to set marginal revenue equal to marginal cost. But remember, you have to look at the two crossing points and see which one's bigger. So there's the hint, and you guys can write it down, and you guys have the question, and you also have your own questions, and we can talk about it on Thursday. Okay, everybody good?
I actually have a quick question.
Yeah, Ian, go ahead.
So the invert and the add and invert again, that math procedure, that's to find the combination of the two firms to get that joint.
Yeah, that what I was calling the joint marginal cost function. But you know, in reality, like I said, the monopolist marginal cost is piecewise, and it's got the low part for the low marginal
Or it
cost,
doesn't
and then
matter
it
if
and
we
then it
get-
switches.
Yeah.
And then it switches.
Okay.
So the thing that I was describing in the very end of the whiteboard lecture was that really, in order to figure out how much the monopolist is going to produce, you've got to calculate the quantity at the intersection for the joint and the low cost firm, and then see which one is higher. So you have to solve two simultaneous equations. They're pretty easy. I mean, the one here, you can see marginal revenue is just going to be doubling the slope there. So you could compute that, and then find the Q that intersects with the low cost, which is the first marginal cost function there. And then you can compute the joint marginal cost function just like I showed you. And then you don't have to worry about the piecewise part. You just find where the joint intersects with the marginal revenue, and then compare the two quantities from those two different sets of solutions. And whichever one's bigger is going to be the answer. Okay?
Thank you. Yeah, that was perfect.
Okay. All right, you guys. Happy quarantine, and I'll see you later.